It's easy to create a box plot to show the relationship between two variables with the boxplotC function. There are two required arguments, dv and iv. The dv argument is set equal to the dependent variable, which should be interval level. The iv argument is set equal to the independent variable, which should be nominal or ordinal level. The boxplotC function has some standard optional arguments. With boxplotC, you have options to weight observations, specify the dataset name, and whether you want to print the box plot to an HTML file in your working directory. The function also has some standard plot-related arguments like main, xlab, and ylab. I will show you how to use the plot-related arguments named box.col, varWidth, and ivlabs in this video. To see how to use the boxplotC function, let's work through some examples together. The boxplotC function is used to generate a box plot showing the relationship between a categorical independent variable and an interval level dependent variable. And that box plot would show you the central tendency of the variable, the dependent variable, as well as its dispersion, and is a nice way to look at the relationship between variables at these levels of measurement. So there may be other uses of box plots out there, like for univariate statistics, but that's not the purpose and the function of the boxplotC variable. The two variables that you need to input to execute this function for boxplotC are the dependent variable dv and the independent variable, which is the keyword iv. So dv and iv should be pretty familiar by now, because they're used in a number of our companion functions. So we need a categorical independent variable and a interval level dependent variable. So I'm just gonna kind of pick one more or less at random here. For my independent variable, I'll use the party ID 7 variable, and then the dependent variable has to be measured at the interval level. So let's try this age. So I'll look at a box plot of the relationship between the age of respondents and their party identification. Give this a run, and it gives us a little notice here, not really a warning, just a heads up that the labels for the boxes are kind of long and that there's a ivlabs argument that can be used to shorten them. And I hit return to see the plot, and so I get this box plot of the relationship between party identification in 7 categories and the age of respondents, and the kind of the dark horizontal line segments within each box represent the median. You see, and then we have the lower 25th percentile to the upper 75th percentile. So this would show like the middle 50% of the distribution is in the box. And then we have it's extending up to the hinges and show like the extreme values. And this isn't showing any outliers here, but the age is kind of a interesting variable, because in a survey like this, they don't ask people under 18 to participate. So the bottom hinge for all the variables, well, I guess except this 5th category, is a little bit higher than 18, but for most of them it's just 18 because that's the lowest age that can participate in the survey. And then the upper age is 80. I actually believe in the survey the response category is age 80 or over, so it's kind of truncated a bit artificially at age 80. But even if it's truncated artificially at 80, those median values would be right, given what we've said about not taking responses from individuals under age 18. So you can see quite a bit here. The relationship between the variables, it doesn't look like there is one, maybe except for kind of a curvilinear relationship perhaps. And then the width of the boxes in this plotting correspond to the number of respondents in each category. So you can kind of see by the thickness of the boxes that they're most respondents in the strong Democrat and strong Republican category, and fewer respondents in the boxes in between. So quite a lot of information conveyed in this one box plot. And we did all that just with two arguments, dv and iv. Okay, I left off, I created this basic box plot to show the relationship between the 7 values of party identification and the ages of NES respondents. And this obviously wouldn't be a causal relationship. This independent variable isn't causing the ages, but it's showing some kind of relationship between the two. I guess for that reason I'm going to change the dependent variable into one you really could assess a causal relationship to. So I'm going to change it to one of our feeling thermometer variables. Let's say to capitalists. So I'm just going to give this another run, take a look at another box plot here. It shows kind of maybe more interesting features of this relationship, where we have maybe it looks like an increase in the median value once we get into the Republican side, and then some of the hinges are more limited. So these little circles are going to be some extreme values that go that are observed that are outside the hinges of the box plot. So that's all well and good. So what else might we do with this? So our technical documentation, the help page for the boxplotC, like our other functions, is going to list the options that go with the function. And for this boxplotC function, we've got some of the usual suspects here that we can use in a function, a boxplotC function call, like W to change the weights, data tag, and printC to print the results to a working directory. And most of the options here are plot related options that you could use to modify the plot. So let's dive into this and show you how we could change the plot. One thing you could do straight away is use this box.call, box color argument if you want to change the color of the boxes. So we have this by default sort of a gray color here, and we can change that to any legal color in the R world, which is yellow. We get sort of a preview of that in RStudio, which is neat. And then we hit return, and then we've got yellow boxes, which could in a presentation wake up our audience if we would like. What else? Another plot related option we have is this var width argument. Now by default, if you look closely here, the width of some of these boxes is larger than the width of other boxes. So the width of the strong Democrat box is wider, and as well as the strong Republican, than the other boxes, because the number of respondents in the strong Republican and strong Democrat categories is greater than the other categories. Now if we don't want to see that, by default you do see variable width boxes, but if you don't want to see that, we would set the var width argument to false. And if we've done that correctly, now all the boxes are the same size width, which the pros and cons to making that choice. The var width shows more information, but if you're not particularly interested in conveying the frequency of responses in different categories and focusing the viewer on the relationship between the two variables, you might want to change it to var width equals false. The boxplotC function, like most plot related functions you'll see in the R companion packages, as well as really any plot related functions in the R world, have options for main, xlab, and ylab, which would allow you to customize the main label of the plot, x-axis label of the plot, and y label of the plot. And you can see on the plot, there's like a default main label generated by the function boxplot of NES FD capitalist by NES party ID 7, which is descriptive and the best description the function can provide given the information provided, but you could customize this to make something more readable. Just the function itself doesn't know what you're intending and doesn't quite speak your language yet, so you can use that main in xlab and ylab arguments to customize that a bit more. Like other functions, you can, like some other functions, you have the ivlabs argument, which you can set equal to a vector corresponding to the values of the independent variable. So if you want to overwrite these rather long labels on the box plot with the numbers on it, you don't really need to see on the box plot. It may look kind of confusing on the box plot too. You can overwrite that for display purposes and supply shorter labels. I've demonstrated this in a few videos, and one trick I would use if I were doing this, well, I am doing it. One trick I would use is to ask R to give me the levels of the variable. Now this is just display the levels. It's not going to change them. But if I want to skip some typing, I may copy that into the space for ivlabs and then edit the levels I was given. This will help with getting the right number of levels, and then should avoid with, make sure that they correspond in the right order, and also avoiding typos. So I just generally like to type less if I can help it. Not just a bad typer, but I guess a lazy typer too. So strong Democrat, moderate Democrat. I will say lean Democrat. Make sure I've got commas separating the values here. Independent, comma, I say they will lean Republican, and the sixth category is I don't like that not very strong. It just seems kind of judgmental to me. So let's say lean Republican, moderate Republican. And then finally, get rid of that 7, and just the last category is strong Republican. Now that doesn't sound as judgmental to me, because that's strong Democrats and strong Republicans, but I don't like that. Weak weak Republican sounds as good, so I'll avoid that. Give these some shorter labels, and I like that a lot better, don't you? So you can see the new labels on my box plot. Nice and symmetrical, fairly short. That probably could be shortened a little bit further. I think for demonstration purposes that should suffice. And you can see how using the ivlabs argument can make the plot more elegant, reducing some of the clutter, and focusing the viewer on the information, exactly the information that you want to convey. And as I mentioned before, the nice thing about that ivlabs argument implemented by a function like boxplotC is you can modify the labels for the independent variable values without actually modifying the levels of the NES party ID variable. So I get some different display labels, but if I were to say down here, look at those levels again, they're the same as they were before. So it's kind of the convenient way to modify the display on the plot without actually changing the variable itself. That way you can get the plot that you want looking right without actually changing the variable and causing unintended consequences for your future analysis.